This is the video introduction to Lesson 19, Multiple LEDs in Parallel, of the Mr. Circuit Basic Electronics Lab number 2. In this lesson, you are going to learn how to calculate the value of the resistors needed to connect LEDs in a parallel circuit. First, I would like to review what you learned in Lesson 18. Suppose you have an LED that has a voltage drop of 2 volts and needs a current of 18 milliamps, and you want to power the LED by a 9-volt battery. You learned that you would need to add a resistor to the circuit so that you would not damage the LED. How big of a resistor would you need to add? You learned from Lesson 18 that the formula is R equals E divided by I, where R is the amount of resistance you would need to add to the circuit, E is the voltage drop across that resistor, and I is the amount of current required by the LED. So, a red LED drops 2 volts, therefore the resistor in the circuit would need to drop the other 7 volts, because 2 volts plus 7 volts equals the battery voltage of 9 volts. Using the formula and substituting the values for E and I, we get E equals 7 and I equals 18 thousandths. Therefore, R equals 7 divided by 18 thousandths, or R equals 389 ohms. So we would need to add a 389 ohm resistor to the circuit. In this lesson 19, we are going to discuss the situation where you want to connect multiple LEDs at the same time. Note, regarding connecting multiple LEDs, you will get erratic results if you try to connect the LEDs end to end in series. In order to get a reliable circuit, you need to connect multiple LEDs in a parallel configuration. Here is a schematic diagram showing 3 LEDs connected in parallel with a battery. You will notice that each LED has its own resistor. How do you calculate the value of those resistors? Answer: you do it the same way you did for one LED. Let's practice. Here we have a circuit with 3 LEDs in parallel. Let's do the calculation for one of these LEDs in the group. Since we just did the calculation for one red LED in a 9-volt circuit, we know that the answer is 389 ohms. Therefore, in this parallel circuit, all the LEDs need resistors of 389 ohms. But let's change the voltage to 12 volts DC. How would that change the value of the resistors in the circuit? Well, since a red LED drops 2 volts across it, each resistor would need to drop 10 volts. So using the formula, R equals E divided by I, R would equal 10 divided by 18 thousandths, so therefore R is 556 ohms. So each LED, therefore, would require its own 556 ohm resistor. Now let's change the LED to the color blue, leaving the voltage at 12 volts DC. The blue LED drops 3 volts instead of 2 volts and requires 14 milliamps of current instead of 18 milliamps. So now, with 12 volts and blue LEDs, let's calculate the value of the resistors. The blue LED drops 3 volts, so a resistor would have to drop the remaining 9 volts. Also, remember that the blue LED only needs 14 milliamps of current. So, using the formula, R equals E divided by I, R would equal 9 divided by 14 thousandths. Therefore, R equals 643 ohms. So each resistor in the circuit would need to be 643 ohms. Let's do one more calculation. Let's calculate the value of the resistor needed if we power the circuit by 9 volts DC instead of 12 volts DC. Since the blue LED drops 3 volts, then the resistor would need to drop the remaining 6 volts instead of 9 volts. Substituting these values into the formula, we would get the following. R equals E divided by I. R equals 6 divided by 14 thousandths. Therefore, R equals 429 ohms. Therefore, our resistors in this circuit would all need to be 429 ohms. So let's go over it one more time. The formula for determining the value of the resistor in an LED circuit is R equals E divided by I. That is to say, the value of the resistor that needs to be added to the LED circuit is equal to the voltage of the battery minus the voltage drop across the LED divided by the current required by the LED. These calculations are very important when working with LEDs and electronic circuits. Sometimes I'm asked by model railroad enthusiasts how to connect LEDs to their layouts, and this is the formula that I share with them. If you need to, you can repeat any of these videos in the lab as many times as needed. When you're ready to complete this lesson, go to the questions on page 19B in the lab manual and answer them. When you've done that, you're ready to go on to lesson 20.